Welcome to the IPMWORKS e-learning modules. My name is Tito Caffi and I'm from Università Cattolica del Sacro Cuore from Italy. This video is part of the module number 4, Integrated Disease Management, and it will present chapter 4.2 that is about the case study on arable crops, and in particular we're talking about wheat today. Recently we published a paper about the outlook on wheat health across Europe, and we analyzed what was going on in different experimental trials from north to southern Europe, as you can see in many different states under many different environmental conditions. So we can say that across Europe we have to manage wheat in a very different way, although of course the basic approach is always related to IPM, but for some disease, for instance septoria leaf blotch and brown rust in Italy, we need to use fungicide because they still play a key role in crop protection. You can see that the number of fungicide application is varying, is very different in the different states considered across Europe. We also have some specific limitation due to the role of the plant protection offices, which are ruling how many treatment we can apply. Of course, the different conditions are playing a very important role for the different pressure of different pathogens across Europe. So in some cases we have different epidemics, different types of epidemic that we have to manage, and we have different tools for doing this. About septoria in particular, we need, in the southern part of Europe, we can control properly, and we need to use fungicide to properly control it. The same for brown rust, for instance, but such in this case, brown rust in Belgium, we have resistant varieties that are crucial for a full control. Same thing for Fusarium head blight. In France, we have resistant variety for that they are allowing us to obtain a very nice control of the disease on the crop. Fusarium head blight in Italy can be effectively managed combining resistant variety and a proper fungicide application, particularly in the most critical period, it is, around the flowering time. So we will be back on this. We have a different specific approach on the different situation we are in, but we have to consider the crop, critical point, critical part of the agronomical stage of the crop for a proper intervention at the right time, in the right way, with the proper action. If we analyze the production life cycle of wheat, in particular we can focus on durum wheat, we can highlight that we have many different types of decisions we have to take before, during, and also at harvest and after harvest. So we have land selection, the use of resistant variety when available, type of cultivation contract for producing durum wheat, and we have a specific cost-benefit analysis that is needed to all this selection. Then we have many agronomical and phytopathological decisions that must be taken during the cultivation, from the soil preparation, the sowing rate and time, fertilization, water management, weed control, that is very impacting on pest and disease control. So we also have to keep in consideration environmental impact and what we have to do for managing the crop. Crucial decision about the harvest time. The proper maturation is impacting the yield, particularly for what is the quality of wheat. And of course, maybe not for the growers, but after the harvest, we have a lot of quality check and storage condition and marketing aspect that must be taken into consideration. A few years ago, we developed a decision support system for managing wheat crop. Generally speaking, a decision support system is a tool that is providing 4 main steps: monitoring of the crop environment, that is the field, the environment, the crop, and all the surrounding on the crop, how is growing, if it is growing well, if there's any weeds, pests, or diseases that is affecting the crop. Second step for decision support system, collecting the data, making them available, so putting all those data together in a database, making this available for data analysis. Many different type of rule algorithms. Generally speaking, we can have, as we have previously discussed, a multi-modeling approach, so many different epidemiological, or not only epidemiological, many different models that are working together on this data to do what? To implement expert knowledge on the situation of the field, providing some scenarios, alert for the third step, so of a decision support system, providing information about what to do. The fourth step of a decision support system is in charge, of course, of the farmer to take proper action. So in this course, after an action that has been implemented or not, we have to go back to put it into the loop of information to get back again once more in this loop. This flow of data and information can allow to take decision, timely decision to protect our crop. From many different point of view, crop rotation, it is a crucial part because we can choose the proper variety and, if available, a resistant variety for a specific crop according to what we were growing on the same field before, with a different level of let's say risk according a residual disease pressure, a residual fertility, and expected income. So the DSS can help us giving information to the DSS about what we were growing previously. The DSS is giving back a feedback about the different level of risk. So we can select both crops and indices of interest and look for the scores. The higher the better, of course. We can the higher the better to be discussed, because we can have a very high risk of residual pressure, so we have to maybe evaluate differently. So again, a very crucial point about the sowing density, the amount of seeds we need for the ideal population of plants in order to maximize the yield quantity and quality, and the time of the season where it is better to sow. We can insert information about what we decide to or what we can crop in our field in order to have a dose of seeds per hectare that is maximizing our yield. Of course, the fertilization and weed management is of great interest and impact. As you know, we have strict interaction, for instance, between the presence of weeds and the aphids, which are vector of viruses. So we cannot do anything against viruses, but we can control and reduce as much as possible the population of the vector. We have to check the growth of the plant, not only because of the phenology, so to follow the development of the crop, but also because the flowering period is a critical window for the application of fungicide in order to control one of the major diseases, at least in southern Europe, for instance in Italy, that is Fusarium head blight. And actually, we developed a specific epidemiological model you can see on the left of your screen, starting from the mycelium on the inoculum source, how the spores are dispersed, how they can reach the head surface, if they are infecting. So from one side we can have Fusarium head blight symptoms, so let's say the appearance of the disease, so how much is the risk of having infection. And from the other side we can, according to the environmental condition, the growth stage of the plant, the evolution of the pathosystem in general, we can quantify the iphy infecting kernels, and so how much mycotoxins we can have in kernels. From the graphical output, we can see an infection risk that is strictly related to the flowering period. You know that the shape bell curve is mostly mimic the flowering period, while the dawn risk about the oxyvanenol risk is about the mycotoxins that can increase according the specific condition and the situation, of course, without fungicide application. We tested this decision support system, of course, and we can quantify in different way, as again we have seen in previous modules of this course. We can quantify the difference in yield in terms of quality, so meaning the protein as a percentage of dry matter, the weight, and the oxyvalenol contamination in the kernels. That is, the objective is to reducing as much as possible. As we can see from this publication, we have, with the sustainable cultivation, so using the decision support system for taking the practices, for taking the decision related, the action for management, particularly from the point of view of the crop protection, we had the same result of the farmer, with a little bit less of presence of the oxyvalenol, but we are quite below the threshold, and so there was no problem. So there's no difference, but the yield was significantly higher in both seasons, and the impact in terms of carbon dioxide equivalent per tons of grain produced was lower. so we can obtain the same result, reducing the impact and so increasing a little bit the yield, the monetary yield, the income, because we can optimize the activity we are performing to the field. Very specifically on crop protection and the intervention on against Fusarium and blight, you can see here two different types of fungicides applied at different days after the infection. 10 days before infection, 7 days, 4 days, 1 day. The optimum efficacy for both the fungicide is the closest as possible to the infection time. Always before the infection. We have to spray in a preventative way. If we are in delay by 3-5 days, irrespective of the type of fungicide, there is a risk of having infection, having Fusarium and blight symptoms in our field, and having the production of the osivanol on the kernels. So it is really important to monitor the season, the environmental condition, to see if and when it is necessary to spray. This is a case of the season 22-23. We are in the north of Italy, production of durum wheat under organic and IPM condition. So we have 3 different fields where we have a set of different trials. You can see in the graph, in the left side graph, the risk for Fusarium and blight really following the flowering period and the evolution of dawn. That was not much. A huge increase of septorial leaf blotch and brown rust, more or less a little bit earlier actually than the risk for Fusarium and blight. But I'm showing this graph not to get into the detail of the different models, but just to tell you that a decision support system is also useful to putting together many different pieces of information, not only focusing about one single disease, but having a plenary look of the situation. And in this case, we can, okay, of course, we have to spray. In Italy today, we can spray only once, only one fungicide all over the season, all over the season. So one shot is necessary for Fusarium and blight, but since we have this condition, this situation of risk for septorial and brown rust, most probably we have to select a proper fungicide that can be useful to cover all the 3 different type of pests, of fungi. So protecting the spike from Fusarium and blight, but also protecting the spike and the upper foliage from the other leaf diseases. We were also using the application of such a type of model and decision support system. This is a 3-year experience. We are still in north of Italy, in particular in the Piacenza County, and all the little dots you see on the map are fields of durum wheat used for pasta production. And using the DSS granoduro.net, we were categorizing the risk level, green, yellow, or red, and the frequency obtained in the different valleys. Here in Piacenza, we have 4 different valleys coming down from the Apennines, and we are dividing the different zones according to the valley. We use this scheme just to testing Of course, all the grains, all the kernel produced in the different fields are tested when they are delivered to the pasta producer. But combining the application of the model, it is of course, I hope I was able to give you the highlight how it can be useful for the practical and proper management of the crop when it is in the field. But in this way, it can be useful also for increasing or decreasing the number of testing if the grain is coming from a field coming from a different valley, and if it was categorized as yellow, so medium or low risk of Fusarium and blight. Of course, if it is red, everything must be tested twice. So this type of application can also be useful for logistic management of the delivery of the kernels to the pasta producer. Thank you very much. I hope you enjoy this arable crop case study on wheat. Thanks a lot and take care.